with another LeetCode video. So sorry for the gap yesterday. I was a bit busy, but let's get back to the question. Let's get back to our streak of doing questions every day. So today our question is going to be car fleet. So this is kind of a stack implementation question. So you have to implement a stack in this question. So let's try understanding the question now. So there are n cars going to the same destination along a one lane road. So it's a one lane road and the destination is target miles away. So target is a input, and then each element will have a position and a speed respectively each car. So where right position, okay, so this is understood. So one car can't cross another car because all the cars are in one fleet. I mean, not fleet, they're in one lane road. It's a one lane road, so you can't cross one another. The faster car will slow down to match the slower cars. The distance between the cars are ignored. The car fleet is a non-empty set of drivers driving in the same position and same speed. Note that a single car is also a car fleet. So a car fleet is kind of like a convoy. So imagine you have two cars. Okay, let me show the representation of it. It's a funny representation, that's fine. So imagine there are these five cars, 1, 2, 3, 4, and 5. So imagine all these cars are one behind the another, like one is two is behind one and so on. So all these cars would make a fleet because there's no gap between them. So imagine the car number 1 is going at 5 kilometers per hour, 2 is going at 5 kilometers per hour, and 3, 4, 5, all three are going at 5 kilometers per hour. Then our value, like the number of car fleets would be 1 because all are having constant speed and they're sticking to each other. Like imagine all these cars are only one car, so it would be one car fleet, that's it. So let's see the first test case. So imagine this target 12. So imagine at position 12 is all the cars want to go to a position 12. So and their respective positions are given here. Let me zoom in. Their respective positions are given here. So the respective positions are given here 10, 8, 0, 5, 3, and their respective speeds are also given here. So based on that, we have to see number of car fleets. Let me explain this test case specially. Let's see the question now properly. Yeah, you see here the target is 12, and then we have the positions and their speeds respectively here. So one thing we need to consider is that without sorting the both the arrays, like in the sense like without sorting both of their indexes, we can't approach the answer because these are positions. These are something which are there in the real time scenario right there in the question. So imagine he told let me see, wait a minute. Okay, so there's one car at position 10 and its speed is 2 kilometers per hour, and a car at position 8, its speed is 4 kilometers per hour, and a car at position number 5 and its speed is 1 kilometer per hour, and a car at position 3, it's 3 kilometers per hour, and then a car at position 0 at 1 kilometer per hour. So this car is going to take 1 second. You know the formula for time, right? Time is nothing but distance by speed. So the position at right now the position is 10 and the destination is 12. So 12 minus 10 is how much? It's a 2. So 2 by the speed is going to be 1. So this car is going to take 1 second to go to its destination. All the cars have same destination, we have to keep that in mind. So a car at position number 8, so it's going to take 1 second too, based on the formula. And then we have one more car which is at 1 kilometers per hour. It's going to take 7 seconds, and this car 3 and this car 12. So similarly the same formula is being used for all the cars here. So imagine this car is going at 1 kilometer. Even these two cars have the same speed, so they would both meet at 12. So both would reach the destination same point, so they would create a fleet here. But this thing is going to take 7 seconds, so this is going to take lesser time. But problem is that the question has clearly stated that one car can't cross the car which is in front of it. So the car which is at position 3 can't cross the car at position number 5. So this car can't cross this car. So that's why they both create a fleet. So this is going to be the second fleet. This is the first fleet. So 4 and 2 are going to create one fleet, 3 and 1 are going to create one fleet, and 1 is going to create a separate fleet because it's going to take 12 seconds. It is the slowest car and it's farthest from its destination. So that's the time. So here you see, we are going to use a stack. I'm going to explain properly how. So imagine initially we are going to iterate from the right to the left because this is what is important for us, like initially in the stack. So time 1 is present here. Initially time 1, there's one car here already. and then next car is going to income, like it's going to come. So with time 1. So 1, there's no point of keeping 1 here because these both have already created a fleet. They both are like equal. So imagine there's one more car coming in, like 7. So 7 and 1 is present here, okay? So 7 is greater than 1. So you can add it to your stack because it is of a lesser speed, and that too it won't create a fleet with your car. There's no problem with that. And number 3 which is present, so number 3 can't be added. The reason why number 3 can't be added is that it's faster than the car in front of it. It can't cross, so they both will create a fleet. So 3 can't cross 7. So 3 will, so this car will maximum come behind it and create a fleet with it. So that's what is going on here. And then last car, it's very slow, as you can do it. That boss is coming by his own wish. He's okay even if he's late. So we can add it separate to our fleet. So our stack is going to be 12, 7 and 1. So the size of the stack is going to be 3. So that's why we have 3 fleets on the cards. So the approach is pretty easy. Let's check the implementation right now. Okay, so you can see here the car starting at number 10. So here number 10 and number 8, I mean, yeah, number 8, these two become one fleet, and then uh, these two become one more fleet. They meet each other. So based on the positions, it matters. So let's try coding it up now. So initially, we'll create one hash map. So we have a hash map here, and then we are going to store the values of the position and the speed in them. So that we can sort them easily using the tree set. So let me start iterating. So, so we are iterating from 0 to the whole array. So and our next step would be to a map. We're going to add our values. So map dot add. So it's going to be position. I hope you guys can see the screen. It's zoomed in enough. So position of I, and then we're going to add the speed also. So these both are added. So far it's good. Okay. So we have created our hash map here. No problem. Next we're going to use our tree set. Tree set has a property in Java. It belongs to collection framework. So thing is that tree set will naturally store all the values, the keys based on the order. Like it sorts it and keeps it. So as you add it, organically sorts it like naturally. So let's create the tree set, and then so our preset is created here successfully. So and we'll take all our hash map values and add it to our tree. And dot put all is the function. So we're going to add the map here. So now our tree set is kind of sorted. Now we can happily iterate through our tree set. So for that we'll use the for each function. So map dot entry, and it's going to be integer and integer values, and then entry. We are using the for each function to iterate through the tree set. So the tree dot entry set. So now this is fine. So now let's iterate. So right now to get the value we have two functions. To get the key and the value pairs, to get the key and value pairs of our tree set. So there's a function for that. So it's called get key and get value. So entry dot get key and our entry dot, these two are our main functions so that we can call our get our values of the tree set. So let's test this out once. Let me output this just in case. Let me just copy this here. get value. So we have both of them here. Let me put a so that we can view it properly. Let me zoom out once. So you guys can see here the input. Let me open the console here. Okay, so you can see the input here. So here we are passing these. Let me so here the input should be integer value. So right now I'll add a dummy value just for our testing, to test the functions of the entry dot get key and get value. So I'll return one just for now. We'll so at each stage we'll try testing our code so that we can understand whether we are going in the right direction or no. Map.add is wrong. So for such things, map.put, it's called map.put. Open inspect by mistake. So it's map.put. Why did I press the save button? Okay, let me run. Tree set. The tree set is going to take how many values? Okay, the tree set has to take only one value, I guess. Tree set dot put all map. Okay, let's see what the problem is. Cannot find symbol map dot entry. It's supposed to be the small m. We have a typo there, no problem. And let me run. Any other errors? Map package map dot doesn't exist. Sorry, wait a minute. Map dot entry is going to be a biggie. If we run again, such errors pop up in a nice way. Yeah, so we need to resolve this. Wrong number of argument required one. Only tree set takes only one argument. My bad. So I don't know where the mistake is. So guys, I've understood where the problem lies. So it's supposed to be a tree map. I used a tree set by mistake. My bad, guys, because this is the first time I'm using a tree map in a question. So put all dot map. Now let's try running the code. I meant it has to have two arguments. Two are required here. Now you can see this is 0, 1, 33. Let me put a gap in between so that you can get the values. So you can see, let me zoom in, you guys can understand better. So there is a 10, 8, 0, 5, 3, and so we sorted this like based on its values. So 10 and 2, 8 and 4, 5 and 1, 3 and 3, and 0 and 1. So this is sorted. So this is what we needed to solve the question. So let's get back to our question. Let me close the console. So we are getting these values. So now we need to add all this. We need to create an array which stores uh, all the values of the time. So we need the time for each one of them. So what's the formula for time? It's going to be the let me type it down here. So time is going to be the target where you're supposed to go minus the current position. Let me zoom in. Yeah. So the current position, the whole thing divided by the speed of the speed of the car. So now let's create a array which stores all the speeds. I mean the times. So it's going to be a character array. It's going to be times. I mean it's going to be double. I do such mistakes every time. It's going to be double. Because when you find this time, sometimes we may get a decimal value. So for a better comparison, we need it. So it's going to be of the size. It's going to be same size as the array. Speed or length. And now, So let's take our values of get key and get value. So times, so we need a pointer so that we can add it properly. So our initially our pointer will keep it as 0. So at initially pointer is 0. So times PTR is equal to, now our formula comes into action. So what is the formula? So it's going to be target. It's going to be target minus the entry dot get key, which is going to be the displacement. I mean the current position, the whole thing divided by the get value. Yeah, this is our times PTR, and then every time we increment the PTR value. Yeah, I think it's good now. Okay, and then now let's try seeing the value of PTR. Okay, leave. We get we are in time. We are storing each time of the car, time taken to reach the position. Now we need a stack as so a stack is going to be of the type double, because we are storing time in that. Stack double new stack. So we have created a stack here. So now we'll iterate from the last to first. So it's going to be speed. Let's put it as a time dot length, and I should be greater than or equal to 0, and then I minus minus. So if it's empty, then we add a value without any problem. Stack is empty. Stack dot push times of the I value. No, okay. And then if at all the incoming value, if the times of I, it's greater than the stack dot peak value, it's greater, then we would add it. So if the time is lesser than if the previous car, I'll show it properly. So this car you see, okay, so let me tell. Yeah, you see this car which is taking 7. So this car at position 5 is going to take 7 seconds to go, and this other car is going to take like 3 seconds to go. This car has lesser speed. I mean lesser time but more speed, but they both are going to create a fleet. So it's 1 unit only. So you just add that to our stack. I mean STK dot. So then only we would push it, and then in the ending we will return the stack size. Let me zoom out. Yeah. Let me run the code and check. Hope I don't get errors. Yeah, it got accepted. Let us do for us those test cases which the question wants us to do. Wait a minute. Okay. So you can see here it's target 10 position 3. Let me put that. Target 10. It's going to be a single array. If it works for this kind of edge cases, then our code will work for everything else without any problems. Yeah, it works. Now let's submit. I already submitted once. We have a mistake here. Let's see where our code is failing. Let me just do one thing. Yeah, so 10, 6, 8, and the output is coming as 1, but it's supposed to be a 2. Let's check that test case out now. So it's greater than or equal to 0. Okay, there's no problem in that. Times of I stk dot size. Let's see where our thing is going wrong. So guys, I've understood where the problem is. Actually, it's supposed to, I'm supposed to upcast the thing to double. Then it must work because it's not taking decimal values into consideration. Yeah, now it worked out. I've messed up some parts. Like it's supposed to be a tree set. Instead of that, I put a tree map. I mean, instead of tree map, I would put a tree set. So these were the things. So I hope you people understood the approach, and thanks a lot.